Okay, this is your exam review. If you want to see just the formulas, go back and look at that key that is posted also on Google Classroom. Number one is the Pythagorean theorem. I am looking for a leg. So it's my leg squared plus my other leg squared is equal to the hypotenuse squared. So I know since I'm looking for a leg, I am going to have to subtract. I'm solving for a. So I'll be subtracting 8 squared. If you do 10 squared minus 8 squared, that's 100 minus 64. So a squared would be equal to 36. And remember, in order to solve for a, you would have to take the square root of 36, which is 6. So the missing side is 6. Numbers 2, 3, and 4 are the trig ratios. If you remember those, that's SOHCAHTOA. SOHCAHTOA. Number 2, here's my angle. In reference to my angle, x is the opposite and 10 is the adjacent. So this one would use tangent. So I'm going to have the tangent of 40 degrees is equal to the opposite over the adjacent legs. And then I just have to solve that. In order to do that on this one, I would be doing 10 times the tangent of 40. So my calculator, I'm typing in 10 times the tangent of 40. And rounded to the nearest tenth, you get 8.4. Number 3, here's my angle. In reference to my angle, x is the hypotenuse and 10 is the adjacent. Now the hypotenuse is the hypotenuse regardless of where the angle is, just as a reminder. So adjacent and hypotenuse, of course, is going to be cosine. So the cosine of my angle is adjacent over hypotenuse. This time our x is in the denominator, so I know instead of multiplying on this one, I will be dividing. So it would be 10 divided by the cosine of 30. And again, rounded to the nearest tenth, I get 11.5. Number 4, the angle here. Again, 20 is the hypotenuse regardless of where the angle is. X is opposite of our angle, so this one is going to be a sine problem. The sine of 32 is equal to the opposite over the hypotenuse. So again, we're solving this, so we'll be multiplying 20 times the sine of 32. So in my calculator, I'm doing 20 times the sine of 32. Rounded to the nearest tenth is going to be 10.6. Number 5, this is the geometric mean. We're looking for the length of the altitude, so we're looking for this right here. And if you remember, the geometric mean is proportional. And so it's going to be my unknown over 6. And then 22 over x, because we talked about how that's 3 similar right triangles. I will have to cross multiply this one when I do. X times x is x squared. And then 6 times 22 is going to be 132. So I would need to find the square root of 132. Now if you leave it as a simplified radical, that is 2 on the square root of 33. Or if you round to the nearest tenth, you get 11.5. Number 6, since they were parallel, it is proportional, so you can write a proportion. This one's pretty easy. You could probably actually also do this one in your head, but I'm going to go ahead and write a proportion. 8 goes to 16 as x goes to 18. Again, this would be a cross multiply problem. So that would be 16x equals, and then 8 times 18 is 144. And then I would divide both sides by 16. So that's going to give me x is equal to 9. Number 7, the angle bisector also cuts the triangle into proportional segments. Be real careful on this one. I know it's easy to get this one. It is sideways. So x is to 7.2 as 18.3 is to 7.6. Make sure you're paying attention to that. And you're cross multiplying on this one, 7.6x, and then 7.2 times 18.3 is 131.76. And then again, solving for this one, I would have to divide both sides by 7.6. So the answer rounded to the nearest tenth on this one is 17.3. Number 8, the volume of a prism. The volume formula for a prism is the area of the base of the prism times the height of the prism. This particular prism happens to be a triangular prism. So I'm going to do for the triangle, which is a right triangle, that means that this is the base and the height of the triangle itself, the two-dimensional figure. So it's going to be a half times 2 times 1. And the actual height of the prism is 17. So a half times 2 times 1 times 17 is 17 cubic meters, since we're doing volume. Number 9, the volume formula for a cylinder is pi times the radius squared times the height. It's basically the same as the last formula. We just happen to have a circle on the bottom. It does say to leave it in terms of pi. Make sure you're following directions. So it's going to be pi times the radius is 5 squared, and then 14. So 5 squared times 14 is 350. So the volume for this one is going to be 350 pi cubic inches. Number 10, the volume of a pyramid. The volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. This one happens to be a square base, so that's pretty easy. So that would be 1/3 times. The area of a square is length times width, so 11 times 11. And then we can see the height of the pyramid is 15. So I'm doing 1/3 times 11 times 11 times 15. If I can use my calculator correctly. Here we go. Which would be 605 cubic centimeters. Again, we're doing volume. Number 11, the volume of a cone is basically the same as the last formula. We just know that the base happens to be a circle. So it's 1/3 times pi. Now this time it does say round to the nearest tenth, so I'm going to use 3.14 for pi. The radius is not 18. Remember, the radius is going to be half the diameter, so that's going to be 9 squared. And we can see that the height of the cone is 26. So 3.14 times 9 squared times 26. And 1/3 of that would be 2,176.2 cubic meters. So that's number 11. Now number 12 asks us what kind of triangle this is. So in order to do number 12, I'm going to graph it first because I need to see the visual. So I'm going to come down here to my graph paper and graph number 12. All right, so the coordinates that are given to me for number 12 are J is at -2 and 3. So there's J. K is at 1 and 6. 1, 2, 3, 4, 5, 6. There's K. And then L is at 5 and -1. 1, 2, 3, 4, 5, -1, L. Okay, so the reason why we graph it is because that makes my job a lot easier. So this is obviously not a right triangle, and it's not an obtuse triangle. So as far as angles go, we can classify this as definitely an acute triangle. Now, as far as the sides go, it's obviously not equilateral, but it might be isosceles. I'm not too sure. It looks like this side and this side may be equal to each other. So I'm going to check that. In order to check that, I do have to use the distance formula. Again, the distance formula is on your answer key that's posted elsewhere, so please go take a glance at that. I'm going to find the distance from K to L first. So I'm just using those coordinates that I have. So that's going to be 1 minus 5 squared plus 6 minus -1 squared. 5 minus 1 squared is what? 16 plus 49 square root, and that's what? 65. Now there's really no reason for me to find the value of the square root of 65. I just know that's the value from K to L. I need to do the same thing from J to L to see if I can end up with the same length. So the distance from J to L, I'm going to do the same thing using the distance formula with the coordinates that I was given. J is at -2 minus 5 squared plus 3 minus -1 squared. So again, I end up with 49 plus 16. So the distance to that is also the square root of 65, meaning these two sides are actually equal, which would make this an isosceles as well. So make sure you are classifying it with both angle and side references. So that's number 12. Number 13, let's go back up to 13. Write an equation to the circle. Remember, when you plug in your center, the signs are going to change, so it will be x minus 2 squared plus y plus 4 squared, and then you have to square the radius, so that would be 25. Again, the formulas are on the other paper. Go look at them. Number 14, same thing, but backwards. We're actually pulling the center and the radius. So the center here would be a positive 4 and a positive 8. And I have to take the square root of 9 to get the radius, so that would be 3. Number 15, we can see that PQ is tangent, which means that this has to be a right angle. That was one of the properties we learned. We were given that angle P is 16 degrees, and our job is to find the angle there at O. We know that 3 angles in a triangle add up to 180, so 16 plus 90 is going to be 106. So 180 minus 106 is going to be 74 degrees. So that's the value of the angle at O. Number 16, we learned that whenever two chords are congruent, then the central angles that are created are also congruent, so x is equal to 64 degrees. Number 17, x is an inscribed angle. You're given the arc that it intercepts. Remember, the arc is 2 times, so I need to find a half of 58. Excuse me. Yeah, 29. Just double checking myself. I'm going in a hurry, so I have a tendency to make mistakes. So 29 degrees is the value of the angle there at A. Number 18, since the angle is on the exterior of the circle, I know that I'm going to take the two arcs, which are 116 and 40. I'm going to do a half of their difference. So 1/2 of 116 minus 40. So 116 minus 40, and half of that is going to be 38 degrees. So the measure of angle A is 38 degrees. Number 19, we're looking at the lengths of the chords here. Remember, the rule was that you multiply the length, so 5 and x, and then 24 times 8 is going to be 192. And then I would just divide both sides by 5. So x is going to be equal to 38.4. Remember, just using the two pieces. Make sure you're using the two pieces that go together. Don't just pick two numbers. Number 20, we're looking for that angle whenever we have two chords. So here's an angle. It tells me that AB is 20. Wow, this picture is not to scale, and CD is 47. And this is very similar to number 18, but since the angle is on the interior of the circle, we're going to find half of the sum. So a half of 47 plus 20. So 47 plus 20, half of that is going to be 33.5. So x is 33.5 degrees. All right, that's your review.